Hi, everyone. I'm Pareena Verma from ARM, and thank you for having me today. I'd love to talk to you over the course of 10 minutes about really empowering you with all of the learning resources and tools to get you up and running with generative AI on ARM-based CPUs. So there are rapid advancements really being made in the field of AI, and that's just to minimize it and say at the very least, right? We're seeing a visible shift with some of the large language models getting smaller and more efficient and specialized for certain tasks. At the same time, we're seeing inferencing advancing, leading to better performance results. CPUs are advancing in their capability to handle these inferencing tasks, right? So it's just making it possible to run the complex AI models on CPU without any additional hardware. So all of these software advancements, you put that together, along with the powerful and efficient ARM CPU capability, and now you can run generative AI inferencing in your ARM-based servers in the cloud or all the way on the edge on your Android devices, on your mobile phones. So running AI on CPU can really democratize AI, right? It's just unlocking so many new use cases, making it more widely accessible to our community. But at the same time, to really unlock that capability, we feel there's a compelling need to give the developer community very detailed how-to technical tutorials to take advantage of this, to really get you started. And so one of those resources that we've put together is ARM Learning Paths. And these are technical how-to guides to help developers deploy software on ARM-based devices. So it comes with easy copy-paste code snippets. You get your job done, you're running on your ARM hardware, and you're out of there. The learning paths that are available all on learn.arm.com, and you can check them out today, the ones which are focused on Gen AI walk you through things such as like optimization techniques, like what is the right quantization for my model to run on the ARM CPU, all the way through end-to-end workflows of running LLMs with your framework of choice on your ARM-based device. And it's an open source project, it's all on GitHub, so we really encourage community contributions because that's where the strength lies. Now we've looked at the type of resource. I really want to spend the rest of the talk talking about the software advancements that ARM is making with the community to unlock this Gen AI capability. And then along the course of that, I'll highlight learning paths and other resources that you can take home with you and get started with. So earlier this year, we at ARM released a library of kernels, highly performant ML kernels called Kleidi AI. And these are really for AI framework developers with super performant on your ARM CPU. So the GitLab repository is available for you to look at what are these kernels. You can integrate this as source files into your use cases, whether you're running classical ML or generative AI use cases into your framework of choice. And we're working with the ecosystem to make this as seamless as possible for you by integrating it all the way from PyTorch to Executorch, so you're running and you don't really have to do anything that you would do out of the ordinary when using the frameworks. Shown here is a QR code with learning resources, again, around like if you want to look under the hood of like what are these kernels? How do I integrate it with a C++ matrix multiplication example and see the performance benefit that I'm getting on my ARM CPU? And that's for the curious developer. For someone who's really looking to just deploy their use case with an LLM, you'll have end-to-end workflows of integrating, running with PyTorch, integrating Kleidi into it, and then seeing the performance uplift for your AI inferencing on the CPU. So I talked about how it's unlocking this capability all the way from the cloud to the edge. So let's focus on the cloud to begin with. So the ARM Neoverse family of CPUs, which is the family of CPUs powering our ARM cloud-based instances in AWS and GCP and Azure, these family of CPUs have SIMD technology with features such as Neon and SVE, which are really best to optimize and get high performance on your ML and HPC algorithms. So one of the most common machine learning algorithms I'm sure you're all aware of is like general matrix multiplication. It's that complex matrix multiplication of two input matrices and you get one output. There are features in the ARM Neoverse CPU such as like integer 8, matrix multiply, dot product, MMLA instructions, bfloat 16 that are all meant to accelerate those GEM kernels, right? That general matrix multiplication. So linked here are, again, learning resources right on top that will take you through a curated list of how do I run use cases like natural language processing with PyTorch models, all on AWS Graviton instances, and unlock that capability. But if you look further out beyond just the use cases, right, you want to be able to integrate these use cases in a CI/CD environment. So GitHub Actions actually released publicly available native ARM64 runners that will now let you run these ML use cases in your DevOps pipeline. So you've unlocked this capability to have ML ops for containerized AI applications. The runners, PyTorch runs seamlessly on the ARM Neoverse CPUs, just comes together and unlocks that story for you. Now we're further accelerating, running PyTorch and the AI inference with PyTorch in the cloud by integrating Kleidi, the kernels that I just spoke about. So, let's imagine you're running a use case, whether it's classical ML like object detection or image classification, or you're running an LLM. You're likely running a large number of layers, right? And you're using the Python API and PyTorch. Now, if you take any one of these layers, what's happening is it gets implemented as an operator, which gets lowered as a PyTorch A10 tensor. Now, from there on out, you can accelerate the operator multiple ways. You can use the OpenBlast backend. You can use 1DNN with the ARM compute library, which has GEM kernels for bfloat 16 and FP32. You can accelerate directly via A10 by integrating Kleidi. Well, we'll come to Kleidi. You can go through A10 or directly through the ML compiler. Now, Kleidi can be integrated any one of these ways to accelerate your operators. So we've worked with PyTorch to directly accelerate PyTorch through Kleidi by integrating it through that A10 route. And if you swing by our booth, you can see a running live demo where you're running the Meta Llama 3.1, 8 billion parameter chatbot model, all in an AWS Graviton 4 instance, powered with the ARM Kleidi kernels running on these ARM Neoverse-based CPUs. You have a learning path linked at the bottom where you can go and replicate this entire setup in your own development environment. So it's not just a nice, shiny demo by our booth. You can prove it for real. We're actively also working on unlocking Gen AI on the edge. So on mobile devices, on your Android smartphones, or even on the IoT, Raspberry 5s, and all the way down to like microcontrollers and micro NPUs. So think about some of like the common use cases on your smartphone. Some of these AI workloads are already running on the ARM-based CPU on your Android phone without any extra involvement from any other accelerators. So we've created at ARM demonstrators where you can run a real-time voice assistant. You can do group chat summarization. You can do any text-based summarization and run chatbots on these Android smartphones powered with ARM CPUs. And all of those demos will be translated as learning paths coming soon, which will let you duplicate, again, all of this great capability in your own hands and set up your own applications. We've created content, again, linked here, which shows you how you can take performance benefits of Kleidi by running like the Gemma 2B model in Google's Media Pipe and XNN Pack, and you can see the performance uplift on the AI inference. We've done the same with ExecuTorch. We're working very actively to upstream Kleidi into ExecuTorch, which will be available imminently. But today, you have learning paths that can show you how you can run this Llama 3.18 billion parameter model with ExecuTorch on your Android device or on your Raspberry Pi 5. And as soon as Kleidi's upstream, it'll seamlessly get updated. You'll see the performance uplift in like your tokens per second for both the text generation and the time to first token. So again, a reminder, all of these links will take you through those curated list of resources that will let you get started on that journey today. To summarize, I want to leave you all here with really a commitment from us that we want to share everything that we're doing to accelerate Gen AI on ARM-based CPUs with the community at large. But we're only as good as the feedback that we receive. And so it's also a call to action to help us really shape the support that we're offering you and reach out to us over GitHub or directly and help us create the kind of content that you need for your application to take advantage of the fact that you can run Gen AI on these ARM-based CPUs. And please engage with us in our vibrant ARM developer community. It gives you a platform to really showcase your work, but also learn from your peers. And with that in mind, I'll wrap it up, but please stick around for Sunita from AWS is up next. And she is going to talk to you about the optimized performance of the PyTorch inference on AArch64. So thank you for attending. If you have any questions at all, swing by our booth. I'll be right there, or feel free to talk to any one of our colleagues and watch our awesome demos at the booth. Thank you.